Hi, folks. My name's Matthew. I'm an augmentative communication clinician and speech pathologist here at Tech Access. I'm the program chair for the Assistive Technology Conference of New England, which has brought us all here today. Just a little bit of housekeeping. You will be receiving an email from me somewhere around the middle of this week that'll have a few things in it. There will be a link for a survey for today's session. We'd like very much to get your feedback on today's workshop. There will also be a link to the AAC Institute where you can go to get your continuing education credits for our 3 hours this afternoon. In a moment, I'm going to hand it over to Ken. Ken is the president of volkswitch.org, an organization devoted to the democratization of assistive technology by leveraging the power and promise of 3D printing. Prior to his current position, he worked for almost 3 decades as a systems architect for AT&T Bell Laboratories and its subsequent divestitures. He has a Master of Science in Systems Engineering from the University of Arizona and a Master of Education in Special Education with a concentration in assistive technology from Bowling Green State University. Ken has been our guest a number of times. I believe this is his 3rd time presenting for us here at ATCNE. Always very informative, so we're very much looking forward to it. If you guys have questions as we're moving along, feel free to post them in the chat, and we'll be keeping our eye open for that. Ken, are we taking a break somewhere about halfway through?
Yeah, I've got a timer set up for an hour and 31 minutes from now, and I'll try to take that break appropriately around that time.
Okay, and also just to make everyone aware, we are recording this session. Ken is going to make it available. There's a link I sent earlier. If any of you need the link, you can always reach out to me after the session, and I'll be happy to share that with you. So without further ado, I'm going to hand it over to Ken.
So good afternoon, everyone. Let me first clarify why you're not seeing my face, but rather a logo for Volkswitch, and that's because my only free webcam is just pointing directly at this contraption that I've set up to be able to show you top down some live items, and you wouldn't actually be able to see me anyway. So please forgive the fact that you're going to stare at my logo for the entire time if you're looking at that part of Zoom. So anyway, thank you for attending my workshop on 3D printed keyguards. I hope in these 3 hours to share with you almost everything I know about designing 3D printable keyguards for AAC apps. The workshop begins with the basics and progressively adds more specialized content. As you can see, my name is Ken Hackbarth, and you can see my email address on this slide. Note that there are 2 S's in Volkswitch. Please feel free to contact me with any questions or ideas you may have. You're also encouraged to
Ken, I muted you by accident. Apologies. Can you unmute yourself, please?
Unmute. Okay. Hear me
Sorry
again?
about that, everyone. Yep, we're good.
And I don't know if I'm just going to step back a few concepts. So please feel free to contact me if there's any questions or ideas you have. You're encouraged to ask questions throughout the workshop by posting them in the chat window. It'll be a challenge to present and keep an eye on the chat window, but I hope to have answered all your questions by the end of the workshop. And if you haven't already done it, please download a copy of the slides and follow along with me. There'll be times when I'll have a slide covered by another window, and it'll be helpful if you can refer to your copy of the slides for what may be obscured. Many slides have hypertext links to relevant pages on my website or to other websites. They should appear green and underlined. I have no relevant financial relationships or relevant non-financial relationships to disclose. As Matt said, the workshop is being recorded, and I expect to have the recording posted on my website in the next couple of days. It'll be on the In the News page. And if you're not watching this workshop live, please consider making a donation to the sponsor of the conference via the link on this slide. Also, I hate to admit it, but I have Comcast, and lately Comcast has been problematic. So if I lose internet, Trust me, I'll be back in 5 minutes. I just have to reboot my gateway. Please hang in there. All right, as I said earlier, please use the chat window to ask any questions during the workshop. I'll try to check the chat for questions before each slide change. And also we'll take a 10-minute break about halfway through the workshop. Now, here's what I'm going to talk about today. We'll 3D print the same Keyguard that we'll be designing during the workshop. And because the printing process will take almost 3 hours, we'll start the printing before we actually start the designing. That's backwards, but we really don't have a choice. I'll try to justify why you should 3D print your Keyguards rather than purchase them from a commercial supplier. I'll show you some sample 3D printed Keyguards and how I've organized them into 3 categories. We'll step through the process of designing the Keyguard that's going to be printing. We'll cover how you can add advanced features to your Keyguard without ever leaving the simple, just checking over here to see if there's anything interesting going on the screen. We'll cover some advanced features for your Keyguard that you can do without ever leaving the simple user interface you'll see momentarily. We'll talk about hybrid Keyguards, which will probably end up being your most common type of Keyguard. And then we'll open the door completely and show you how to design a Keyguard for almost any app or keyboard. And finally, we'll leave tablets behind and talk about Keyguards for other devices altogether. And just to manage your expectations, I want to be upfront about what we won't be covering, though I do devote a few pages on my website to these topics. And it just occurred to me a little while ago, I should clarify, we won't be talking about what is a Keyguard and why it's useful. I'm assuming you wouldn't be here if you didn't already have a pretty good sense of that. So I'm not going to talk about the mechanics of a 3D printer or types of 3D printers. I won't be recommending a printer for you to purchase. There are lots of ways to get a 3D print even if you don't have a 3D printer. And we're not going to talk about filaments. But I will say this, just use PLA, short for polylactic acid, unless it simply won't do what you need. And finally, if you're already familiar with Thingiverse and have used the Thingiverse customizer, we're not going to be doing that. It's underpowered, it's fragile, and you'll see it's no fun by comparison to what we're going to do. All right, as I said earlier, it can take several hours to print a Keyguard, and we only have 3. So we're going to start printing a Keyguard now, even though we haven't theoretically designed it yet. So I've got the design ready to go in the form of an STL file, and I'm going to drag and drop it onto a slicer program. In this case, I'll be using Prusa Slicer, which came with my Prusa 3D printer. I'll click on the Slice Now button. And because I've already told the slicer in advance how much I paid for a 1 kilogram roll of the filament I'm using, it can predict how much it will cost me to print the Keyguard, in this case, 79 cents. And it can also predict pretty accurately how long the print will take. In this case, it'll take us about 2 hours and 42 minutes. Then I'll click Export G-Code and put the slice design on an SD card. I'll move that SD card over to the printer and beginning the printing process. And then we'll check back periodically during the workshop and see how it's going. So let's just do that. And let me go back because I didn't mean to move that slide up yet. So this is Prusa Slicer. And let's see, we'll go up one here. So this is the STL file that I already created and that we'll be designing this Keyguard as well. So I'm going to just drag this and drop it over onto the slicer. This is the Keyguard that we're going to design, and we'll start printing it now. Well, first I have to slice it. That's this button down here. Doesn't take the slicer very long to do this, and it even gives me a handy button to send that information, this G-code file, over to the SD card. And I believe it's already done. So let me pull the SD card out. I'll bring up my first cam over here. That's the printer. And I have a close-up of the control panel on the printer. See, I'll push the SD card in, select the workshop, and what you see here is the Keyguard will print at about 215 degrees Celsius. That's the temperature of the filament so that it melts properly. And this print surface here, that will be heated up to 60 degrees Celsius. And once those temperatures are reached, you can see them climbing on the, whoops, I shouldn't have done that. Should straighten itself out eventually here. Once it reaches those temperatures, it will just begin printing. Let me see if we can make some progress on the slides in the meantime. So that little display is a little overly sensitive to being touched. All right. So why am I 3D printing the Keyguard rather than purchasing it from someone? Well, the most important reason is cost. So you saw that it's going to cost me about 80 cents to print this. And that's the cost of the filament. It could cost me $80 or more to purchase that, or a similar Keyguard anyway, from someone else. And importantly, if I mess up the design of the Keyguard and mess up the design as far as how I request or specify it in my order, and that Keyguard doesn't fit, if I mess up my design that I'm doing right now and it doesn't fit, well, I'm only out 80 cents. But if I mess up my order with a commercial supplier, then I could easily be out $80. Because there's so much variation in tablet cases, looks like we're actually beginning, let me interrupt here for a moment. Looks like we're beginning to do something on the printer. Let's see it. So it's going and doing some leveling of the build surface before it begins. And this is all done pretty automatically on the Prusa. Pretty cool. In Canada, custom Keyguards can cost a minimum of $300 to $500 to start. Wow, that's a terrible, terrible conversion rate. I thought the Canadian dollar was worth more. That's a joke. $300 to $500. I don't know how they justify that. All right, so it's beginning to print. Is printing its first layer, and it's kind of uninteresting at this point because you can't tell what's really happening till we get at least the first layer down. So yeah, there's a lot of variation in tablet cases, and you're going to need several options for mounting your Keyguard to the tablet and to the case potentially. Commercial laser cut Keyguards are made out of a sheet of plastic, and slide-in tabs are about the only possibility, but that could end up making a screen protector ineffective if you have a screen protector as part of your case. Low cost of printing and basically fast turnaround, 3 hours or 2 hours and 42 minutes from now, we're going to have a ready to test out Keyguard. So it's a fairly fast turnaround compared to weeks of ordering and waiting for delivery. But that can encourage you to work with the Keyguard user to refine your design until it's really a great fit for them. And it can become a highly personalized device. Such devices like that are fun to use, and they're fun to show off to others. 3D printed keyguards can support embossed and engraved text and graphics, whereas on the other hand, a sheet of acrylic comes in only a few colors. 3D printing filaments, on the other hand, come in almost a limitless number of colors. So on the left here, just a few of the colors in which you can find PLA filament. You're not seeing all the silky colors or wood-infused versions that can be even lightly sanded. You can get filament the color of chocolate, but you can also get filament that smells like chocolate or coffee. And on the right, you can see a roll of multicolor filament. This filament, the color automatically changes as the object is printed. And we're actually using filament of that type to print our Keyguard today. It works best with tall items, but you'll even see some effects with this Keyguard. So I'd like to give you a sense of what the Keyguard designer can do, even before you look at it. And we're going to do that by showing you a couple examples of each type of Keyguard. So let me bring up my other camera. So the first category are called grid-based Keyguards. They have a region. There's my pointer. They have a region here that's just a grid of openings, and they may be bordered by one or more horizontal bars that can reach all the way across from side to side. And that bar can be open as it is here or covered as it is here and even potentially down here. You can have lots and lots of openings in the grid. So those are simple grid-based. On the other hand, these are all hybrid Keyguards. And it looks fundamentally like a grid-based Keyguard, but they've been augmented either with special cuts like we have down here, some embossed graphics. Turn that up at an angle so you might see that better. Embossed graphics, engraved graphics, engraved text, and even, shows up fairly well, the outside edge of the Keyguard can have plastic added to it so that it better fits the opening in the case, which may not be perfectly rectangular. Those are all hybrid Keyguards. And then you can open the door entirely and say, I want something that isn't a grid at all. It's a freeform Keyguard. And every opening in this Keyguard is specified as to its size and location and shape. And you can actually replicate any Keyguard type as a freeform Keyguard, but that's just a lot more work than necessary. This may look like it's a grid, but the fact is a grid has more regularity to the layout of the openings. So this is also a freeform Keyguard. So every one of these openings has to be specified, and we're actually going to do one of those later on in the workshop. And finally, and this isn't a 3D, these aren't 3D printed Keyguards at all. These are all laser cut Keyguards. They're cut from a roll, or a sheet rather, of acrylic styrene. So you can use the Keyguard designer to define these Keyguards and have someone else, either your STEM class teacher or Keyguard AT, who used to be called lasered picks, you can have them cut the Keyguard for you, and they'll do it at a much reduced price than their standard ordered Keyguards. And we'll show you how to do that later as well. I should say that a laser cut Keyguard or a sheet of acrylic is the only way you can produce a transparent or really huge, really large Keyguard. Since your printer can only print something so large, but you can get a incredibly large sheet of acrylic, and there are laser cutters that are also very large. So we'll cover all those later in the workshop. Right. So those are the 3 3D printed versions and laser cut, for which you can design what that laser cut Keyguard should look like. All right, so let's talk about designing a Keyguard from scratch. And what you want to do is start with the instructions on this page. Well, it's also this page. So there's a link here, and it'll just take you to this page here, which has, I wanted to point out some video. I talked earlier about there being some additional pages and some videos on this slide, on this web page that will describe much of this process to you, how easy it is to design a new Keyguard, what it looks like to print one, what kind of options you have, and even ways to obtain a 3D printed Keyguard or any other 3D printed AT without necessarily having access to a 3D printer. That's not what I wanted. That's what I wanted. So you can be confident that everything I'm going to tell you today is described on the website, and either on that page or on pages that you can link to from that page. As I said, there's some videos at the top to show you what's possible and how, and a decent introduction to the designer. So you'll get that today as well. So you're going to want to have several items on hand before you begin to design a Keyguard. The first one you're going to want is OpenSCAD, or some people say OpenSCAD, but that just sounds weird. So I call it OpenSCAD. It's a free tool that will support you in creating a 3D design simply by choosing values from pull-down lists. And then we've created a program that uses OpenSCAD specifically for the purpose of designing Keyguards. That's Keyguard.SCAD. We've also put together a data form for you to record the requirements for your Keyguard, a spreadsheet to help you take measurements for your Keyguard directly from a screenshot of the app. And finally, there are 3 files that end in info, which you'll use to create hybrid or freeform Keyguards. And remember, I said that the predominant type of Keyguard you'll be creating is a hybrid Keyguard. So you will need those files. You'll need a graphics program and a text editor. And here are my suggestions based on what kind of computer you use. I don't know a lot about Mac. This was the level of investigation I did. There may be other graphics programs for the Mac that will meet your needs. You'll see what I'm talking about when we use Microsoft Paint to do some of our measurements. I encourage you to make or obtain an easy measurement tool. So it'll help you get accurate measurements of your case. And go ahead and purchase a small collection of I like metal metric rulers. The world of 3D printing is entirely metric. So if you don't have a way to measure in metric units, then you're going to struggle. So your first step is to collect some images, 3 images in particular. You're going to want a picture of the app being used, running on the tablet being used, and the case being used, oriented as it would be when it's being used. So a picture of basically the live programming as would be used. Then take a screenshot of the app in that layout on the tablet where it's going to be used. Save that screenshot as a file on your computer, and you need to check that the screenshot has all the pixels that are available on the tablet. There are just some things that happen. There happen along the way, usually in the process of emailing a graphic, that causes it to be compressed in some way. And so there's a link on this page here that takes you to the number of pixels, horizontal and vertical pixels in an image for every one of the tablets that the designer supports. So just check to make sure when you look at the graphic screenshot that you've captured that it has all those pixels wide and pixels high. All right. So let's go ahead and look at the folder of files for this workshop. And as I said, you need a picture of the tablet. Let me make this bigger right now. You need a picture of the app running on the tablet within the case that's being used and oriented just like it's going to be used by the student or client. Here are those three info files. There's a spreadsheet that just uses input from you that you take from your screenshot and does some calculations for you that will save you a lot of time and headache. There's a Word document, though it's also available in PDF form, just to gather data. And this is especially important if you're working remotely with someone else to get the information you need to create a Keyguard for them. You'll ask them to collect some information for you. This is the designer here. Since I've already installed OpenSCAD, this type of file is already associated with that program. Just like if you had a Word document, it would automatically be associated with Microsoft Word. And here's the screenshot I took from the tablet. There's the demo of the folder content. So here's the app, tablet, and case for which we're going to design our Keyguard. And it's impossible to see from this picture, but the case has some supports on the back that are going to lift the top edge of this case upward. To use the tablet in this orientation, it might be difficult to see, but the camera is on the right here and the home button is on the left. They've actually made a cut in the case so you can access the full home button. So this is backwards from how the designer assumes that the camera and home button are located. And we're going to account for that in a moment. So let me just bring up our live cam here and show you the tablet and case. Here we are, tablet and case. And yeah, it has these little ears that pop out on the back so that I can position it like this. See if I can get that app up and running. Okay, there it is. So this is how it would be used in the field and probably carried like this because the handle's up here. This is how it would be used in the classroom or at home. All right, so we have some specific requirements for our Keyguard. Let's talk about the plan for our Keyguard design. This little green doodle here is supposed to show an approximation of what we'd like our Keyguard to look like when it's on the tablet. We have some things we want special about this keyguard. We want, first of all, we'd like it to expose the vocab button, but we'd like it to cover the rest of this command bar. You see up here, it's also going to cover that region of the screen where it would show the battery status and the current time. We want to completely cover the home button so that whoever's using this can't invoke that, though I know there are other ways to do that in software. But we're going to completely cover the home button, but we're going to expose the camera. And last, we want to engrave the back of the keyguard with the word workshop. That's going to serve as the identifier for this keyguard in the future, and especially be useful if it gets broken or lost and we want to make another version of it. We want to replace it with another 3D printed keyguard. And how is the print doing? So here it is over here. You can see the first layer has almost completed. The printer moves the slowest on this very first layer because it wants to make sure it has good adhesion to the to this build surface, build plate, printer bed, whatever. There are a lot of names for this part of the printer. All right, so that's what our keyguard should look like, and it kind of looks like that right now in real life, but it's going to be thicker than it is now. All right, so let's start the design. And we'll bring up that folder again. And so OpenSCAD's already downloaded, installed on this PC, so I can just double click on this file and it'll launch OpenSCAD and have loaded this Keyguard designer. Like I said, it's just like if you have a doc file, you can double click on it, it'll launch Microsoft Word, and that document will be loaded inside. So this is what OpenSCAD looks like with the designer program, keyguard.scad loaded. There's a version number up here that says it's not the first version, 41st version actually. And I'm going to use my mouse wheel to scroll back. I'm going to roll back toward me to see the entire default keyguard. So this is a visualization of the keyguard as it's currently specified. And in this instance, it's just all the default settings of the designer. So we're going to need, again, starts out way too close. You need to use the scroll wheel to back out to see the entire keyguard. And we're going to set some options to define this keyguard, and they're going to be set over here on the right. This little pane here is called the customizer. It says customizer up top. And we're going to start at the top and work our way down in defining our new keyguard. So if we look at the web page, and scroll down a little bit through some explanatory text, this is really how the web page is laid out. It's laid out as a description from top to bottom of each section, what its impact is, why you would want to choose one item or another. And if I look at the data form too, where are you, data form? So that also has basically the same layout. The tablet case, the app layout, grid layout, all the things that you can specify in the designer, and things that you may want input on from anyone you're working with to design this keyguard. Okay, so we're going to skip the first item there, which is type of keyguard for now. We'll go back and talk about that later. And we're going to instead jump into the tablet section. And this is where we're going to specify the type of tablet altogether. So our tablet is an iPad mini. It's going to be used in a landscape orientation. We're not going to expose the home button, but we are going to expose the camera according to the requirements we came up with earlier. And we're going to swap the location of the camera and home button. So let's just go ahead and do that step. So we've got tablet is an iPad mini. Just choose it from the pull down. Where is it at? Did I scroll past it? Yep, I did. It's an iPad mini. It's in landscape mode. We're going to hide the home button. And we're going to expose the camera. Yes, that's fine. But we're going to swap their location. That's first step. Next, we're going to take some measurements of the case. And I want you to know that the case is critical to your Keyguard design. So first of all, the Keyguard designer can be used to help you design a Keyguard for a tablet that doesn't have a case, but that almost never happens. Everyone puts their tablet in a case to protect it. And the case is going to have a lot to say about your Keyguard. In fact, the size of your Keyguard is totally determined by the case. It's going to sit within the opening in the case. And that opening is always smaller than the tablet itself. So you may find that the tablet is larger than your 3D printer, but you can still print the Keyguard because the case opening is small enough to print on your, or is smaller than the tablet as a whole. And your goal is to mount the Keyguard securely to the tablet, but that'll often require that you leverage specific aspects of the case to hold that Keyguard in place. And I must say, screen protectors are a special problem. More on that later. So the designer needs to know the case opening width, height, and corner radius. And remember to pay special attention to the orientation when you're taking these measurements. What is the width versus the height? Depends very much on what you think as the orientation of the tablet. So let's do a live measurement of our Keyguard, of our case. Here it is. Come on. Okay, very good. Oh, it's because the screen is on. Let me turn this off. No, it's going to be brighter. Okay. There we go. All right. So I mentioned it's really hard to measure the opening in your case without a tool for that purpose. And here's why. So let's say I've got my nice metal metric ruler here. There we go, something that looks like focus. And I put it on one side of the case opening. I lay it on the edge of the case on the other side. Well, there are issues of parallax that make it just really difficult to say, well, down here is the face of the tablet, and up here is the ruler. How different are those two? And you want to have a really nice close fit. So guessing like this is not the way you want to go. And instead, there's a tool for this purpose. Tool you can make yourself. It's all 3D printed, except for, well, there's a bolt here, and internally there's a nut. But what happens with this is you loosen these ends here, as you can see already. These little arms extend outward. And the measurement tool sits on the face of the tablet, and you can slide the arms out until they make contact with the side, and then just lightly turn down these little clamping screws. not too hard because it's just made of plastic. So you want to be gentle with it. And now it retains the width of the case opening, and you'll lay it so it aligns, the outside edge of one arm aligns with the 0 location on the ruler. And then look at the outside of the other arm and see how far that extends on the ruler. And in this example, it extends to 190 millimeters. We repeat that same process for the height. Take my word for it, that height is 125 millimeters. Loosen up the screws, tighten down gently, and put that away for your next, well, actually, I'm sorry, it's not quite done yet. The arms have a special shape on them. You can see this. Get this out of the way. So there are 2 cuts on the edge of the arm. This is the 10 millimeter cut, and this is the 5 millimeter cut. And the way you use those cuts is you'll take the arm and just place it down into the corner of your case. Now I have a picture here that's going to show this more clearly. But you just place it into the corner of the case and use either the 5 or the 10 millimeter cut. And what you'll see is this one. So you'll see that the arm will fit into the corner. And what you're looking for is, does the edge of the cut meet the point at which the curve stops curving and starts going straight again? And if it does, well, then this particular cut tells you the exact radius of the corner of the case. So this is the 5 millimeter cut, and because the corners of the cut hit the point on the case where it suddenly starts going straight again, then that's a 5 millimeter radius. The 10 millimeter cut works for a 10 millimeter radius. And if your corner isn't exactly a 5 or a 10, just take a guess somewhere in between. If it's closer to the 5, it's a 6 or a 7. If it's closer to the 10, it's an 8 or a 9. That kind of thing. Don't have to be too exact here. But anyway, that's how you can use, get you out of the way, that's how you use the entire Easy Measurement tool to take these really critical case opening measurements. All right, so let's enter those numbers in the designer. And what I'm going to point out is you can type those numbers. Where are we at? You can type those numbers directly into these little spinner controls, or you can slide this bar across. If you type the numbers into the spinner control, which is more accurate, of course, then you just have to remember to press the Enter key when you're done. That's all. So let's go ahead and enter those in. Oh, first thing, we're in the tablet case section. Oh yeah, by the way, we do have a case. So select that. And then say what the height of the opening is. It's stuff out of the way. It's 125. And I press the Enter key. Then the width was 190, Enter key, and it has a 5 millimeter radius. So we've now specified everything we can about that case opening. And now we'll gather some more information specifically about the AAC app itself. Let's see. There we go. So Christy says she's had trouble with measuring the corner radius. If you don't have the tool, well, let's try to remember to come back to that at the end of the workshop, okay? I promise we'll come back to that. All right, so we'll get some measurements of the app, but let's talk first about regions of the screen on the tablet. The designer is going to be interested in knowing how much vertical space each of these regions of the app take up. So fortunately, grid-based AAC apps all have a consistent layout. They have a status bar potentially at the top. They may have, I should say this, they may have a status bar at the top. They may have a message bar at the top and a command bar underneath. Then there may be a grid of tiles, and they may have a lower message bar or a lower command bar in place of the upper message bar and upper command bar, or they may have in addition to. So they may have an upper message bar but a lower command bar. The fact is they have some combination of these regions. And the grid and the Keyguard designer needs to know how tall these regions are, because it's going to lay out the grid of tiles based on how much room is left. And I would say if you don't get hung up on the names as much as the fact that there are these spaces. So if you have an app where the command bar is on top and the message bar is below that, well, just call that command bar or measure that command bar and put its value where the designer is looking for upper message bar. And same for the upper command bar. Well, the height of the message bar, put that down here. Just know that the designer is going to assume that this space is on top of this space. Hope that is clear. Don't get hung up on these names. And if you don't have one of these, for example, here's the Touch Chat app, and it's actually been set up so it provides additional space for a keyguard, which means it increases this white area down here. Normally there would be no white area at all, but it's going to squeeze the grid down a little bit to give you some space here. And we're going to simply call this the status bar, this the upper message bar, this the upper command bar, and then we're going to say, we'll just call this the lower message bar, and there is no lower command bar. And the lower command bar then has a height of 0. Anything you don't have, it just has a height of 0. As I say, they're just names. They're arbitrary. They just refer to a region of the screen. And if they don't exist, you'll just leave their heights at 0. Now, some small tablets, and ours is a small tablet, are going to have very thin message bars. So they're not a problem until you add a keyguard. Then you may not be able to see what's going on in that bar, or if you need to get your finger into that bar to delete words or play the phrase, it may be very difficult. But you can provide better visual and manual access to that message bar by adding a bar slope. So what we'll do is we'll just angle this plastic here to give us better access to this space. And you actually can't do that with a laser cut keyguard because unfortunately the laser always cuts downward at a 90-degree angle, and there's no way to change it. So all cuts in the laser cut keyguard have to be perfectly vertical. So this is one of the great advantages of using a 3D printed keyguard. So we're going to definitely be adding a slope here to give us visual access to this and manual access to this, but that means that we have to be cutting into something. So we'll also be covering our command bar a bit. And you saw that with our plan earlier that the command bar is basically covered, but there's a cutout for the vocab button. So the question then becomes, how are we going to get these measurements of the app's layout? And while you could measure the You could measure your app with a ruler. We're going to use a much more accurate method. We're going to use a graphics program to count pixels in a screenshot. And that's why it's so important to get a good screenshot of your app. And a good screenshot means that the screenshot was taken of the app running on the actual tablet where it's going to be used. And then you get it to your PC where you're going to be using your graphics program without losing any pixels. So just verify when you get the snapshot of the screen to your PC that it hasn't lost any pixels along the way. And as I say, that link on the earlier slide will tell you how many pixels you should be expecting. So we created this spreadsheet, and I apologize if you can't use Excel, but this padding and bar size spreadsheet, it'll prompt you for what measurements you'll need to take, and then it'll do some calculations for you to convert pixels into millimeters, which is what the designer is looking for. It can be, whoops, way back. It can be difficult to carefully position a cursor in a graphics program. You're going to need to do that to take your measurements. So you may find that it helps to zoom in on the image, but basically you don't kill yourself getting these measurements. A few pixels here or there just aren't going to matter because pixels are tiny compared to millimeters. All right, so let's get the spreadsheet open. So here's what it looks like when you look at it internally, and I'll open it up a little bit quickly so you can see that it's got every one of the tablets that the designer supports. And I've already scrolled it so that iPad mini is in the top row, so it's nice and close to the column headers. So find the row that represents your tablet, and the values you're going to collect will always be in pixels, and they'll go in this first, let me bring it down again. They'll go in this first set of columns, from this green column to this green column. These are the measurements you're going to take. And then over here are the data you're going to take and put into the designer. And this will all be in millimeters while this is all in pixels. Okay, so we're going to use Microsoft Paint, and let's bring up our screenshot. And I'm also going to bring up this image, which is just the same screenshot, but in Microsoft Photos instead, simply because you can see the cursor over here a lot easier than you can the cursor in Microsoft Paint. In Microsoft Paint, I'm over here in Paint, that cursor becomes a little crosshair, and it might be difficult to see that on Zoom, and it's even difficult to see it live. But we'll take the measurements over in Paint, but I want to show you what we're measuring first in this image, where you can easily see the cursor. So the column headings over here in the spreadsheet, they're going to tell you what you need to measure. So the first thing we're going to measure is the bottom of the status bar. So we're working our way down from the top of the image to the bottom. And we're going to be measuring what is the bottom of the status bar versus the bottom of the upper message bar. It can be difficult to tell where the status bar ends and the message bar begins, simply because there's no obvious graphic line or anything. So you just kind of guess. And what I kind of do is I'm over here on Paint, I just kind of guess, well, I'm probably right in here somewhere is the space where the programmers of this app decided that the message bar would begin. Let me slide this up just for a moment and say, there's a part of Microsoft Paint. Let me see if I can bring it up here. There's a part of Microsoft Paint right down here where it shows you the current position of the cursor. Well, I'm sorry. This is the total number of pixels, And then over here, it'll show you where your cursor is located in pixels from the left and pixels from the top. So if I put my cursor up here, this is the 0, 0 location. It's hard to do. You'll see 1, 2, then what does it say now? 1, 3. The first number, if you just look in that lower right-hand corner, lower left-hand corner rather, the 31 is the number of pixels in from the left. We're going to call that the X location of the cursor. And then the 389 pixels is down from the top, and we're going to call that the Y location. X first, then Y. Should sound familiar if you've had some math. All right, so I would just measure here down and say, well, that is the location of the bottom of the status bar. This is the location of the bottom of the message bar, then down to the bottom of the command bar. It's just telling me across the top here what I want to measure each time. And there's a little asterisk there that just says, hey, if these things don't exist, if the bottom of the command bar is really the same as the top of the screen, just put a 0 in here. All right, so you're going to continue measuring on down the screen until you get to the very bottom of the, says this is the bottom of the command bar, the top of the top of the top button, the top of the next button down. Anyway, it's asking you for each one of these measurements until you get all the vertical measurements all the way down. And your last vertical measurement actually is the entire height of the screen, which Paint will tell you it's 768 pixels tall. So down here is 768 pixels, roughly. All right, then we're going to just take some measurements going from left to right. So the first thing it wants to know is what is the left side of the left button? So that's right here. Then what is the right side of the left button? That's right here. Turns out in Touch Chat, they squeeze all the buttons right next to each other. They take up the entire height and width of the grid area. So the right side of the first button is going to be, or the leftmost button is going to be the same as the left side of the next button to the right. But that's just Touch Chat. There are other apps where there are gaps between buttons, and this is how you account for them by taking these series of measurements. Until you end up with the right side of the rightmost button, and as I said in Touch Chat, that's the full width of the screen because it's using everything possible. So that right side of the rightmost button is going to just be 1024 pixels. Now, fortunately, I've already taken these measurements. I'm just going to type them in instead of trying to move back and forth between the spreadsheet and the Paint window. So bottom of the status bar is 21 pixels. Bottom of the message bar is 62 pixels. Then 106. 106, because again, there's no space between these buttons vertically. 317, 317. The bottom of the bottommost button is 379. Oh, no, sorry, it's 739. The top of the lower message bar is going to be the very same thing, 739. And the top of the lower command bar is 768. You don't need to tell it anymore. It knows how tall the screen is in total because we know the height of an iPad mini screen. So now we start on the leftmost button, and that is 0 because it's right up against the edge of the screen. The rightmost button is 256. Then there's no space between the buttons. That will, I type in, yep, typing back into the same window or same cell. And the right of the rightmost button is the width of the screen. So we're done taking our pixel measurements, and now we're just going to slide over and we're going to see what the spreadsheet is telling us to put into the designer. Close all these down. And it's saying your status bar is 3 millimeters high, upper message bar is 6 millimeters high, upper command bar is 7 millimeters high. Oh, I have an error. Where have I got an error? 2162, 106, 106, 317, 317, 379, 379, 0, 256, 256, 10, oh, sorry, you're right, 256, not 265. That's my dyslexia biting me again. Thank you for pointing that out and not hitting that. Okay, so now I can read here. The upper command bar is 7 millimeters high. Lower message bar is 5. Lower command bar 0. I said we were going to use the lower message bar as the height of that white area that the app gave us for the Keyguard. Left padding, -1. Right padding, -1. I'm not going to worry about these actually. Not sure. Very strange. Anyway, padding, it has to do with if the screen is, if the grid is not laid out perfectly evenly across the available space, then you'll need to add padding, but not quite sure what's going on here, why there's even a -1, -1. There can be -1s, but they should all be 0 with touch chat. So I'm just going to ignore those. And I'm going to go back to here, and I'm going to start putting those numbers in. So the status bar is 3, upper message bar is 6. Message bar 6. Upper command bar is 7, and the lower message bar is 5. Message bar is 5, right? Yep. Okay, now the enter. So the one thing we want to make sure we do is we want to expose this upper message bar because that's what we want to be able to see what kind of message we put together. So we will expose it. Yes. And now it's exposed, but you can see how thin it's going to be until I provide some access to it. And we're going to do that by setting the bar edge slope. It's at 90 now. I'm going to bring it back down and just see what happens. Let's zoom in here a bit. So you can see it's angling as I do this. I'm going to bring it way back even further. I want to have a little bit of a flat region up here, so let's take it up some, say around 35, see what happens. A little more. kind of like that. And this is just taste at this point, whether it's 35 or 37. I just kind of like that angle. So now we have a lot more visibility into that message bar, and it'll be a lot easier to access it. So what do I recommend? Oh, so it should be a 0. Yeah, look, they all went to zeros. Thank you. Because I got to have faith. So how do you judge it? It's by eye. There's only so much you can do. So if the designer only lets you go back to 30, and that just creates this angled top. But basically it's possible that this could be a very thin area, and therefore you want to keep as much plastic as possible there. But with a very thin message bar like we're going to have, I like to give it as much of an angle or reduce the angle as much as possible. It's just taste. I don't know, experience. Try it. Try it once you've printed it. Is it doing what you need to do for you? Yeah, no, it's only changed. The question is this value here only changing the slope here? Is it also changing things here? It's only changing the slope. It's not doing anything to the lines here because that's controlled separately. All right, so let's stop right there for now. And let's go back to our presentation. We've already covered all of these items. We're going to be using X, Y for specific screen locations. That's just how we're going to notate it. So if we have 10, 30, that means the X is 10 and the Y is 30. All right. So we've entered those values. Oh, it looks like I put a 32 in when I did the slides instead of a 37. Yeah. So now let's look at the rails. There's another special topic, and Christy kind of gave us a hint here that might be interesting. The horizontal and vertical rails between the openings in the grid are probably the whole reason for your Keyguard, that they're restricting movements, inadvertent movements of the user between buttons. And so let's look at what drives them. So first of all, one thing to note is the Keyguard is only going to be as thick as the rails are thick or tall. So in our Keyguard here, you'll see that the top of the rails aligns with the top of the Keyguard. And that's always going to be the case. So if your rails are very short, well then the Keyguard isn't going to be very thick. Maybe a problem, it may not be a problem, depends on what you're trying to achieve. There are 3 options you need to understand in order to make sense of what's happening. And here's a cross-section of what a rail is between the openings in the grid. And the rail width is how wide the rail is at the bottom. The rail slope is the angle of the edges of the rail, the sides of the rail. And let's see. Just note that if you're dealing with a laser cut Keyguard, these slopes are always 90 degrees. And the preferred rail height, well, that allows you to control the height of the rail if you can. So let's take a look, for example, here at how these behave. So you're always going to get the rail width and the rail slope you ask for, but and you can make the rail height taller and taller and taller, but there's going to become a point at which you can't make it any taller than it is. It's just trigonometry is going to say you can't get any taller in this triangle. So the taller the rail slope, meaning the greater this angle, and the wider that you make the base, the overall taller the rail can be. And since the keyguard is only as thick as the rails are tall, you can also control the keyguard thickness this way. Note that if you set the rail slope to 90 degrees, so it's completely vertical, well then you can make the keyguard arbitrarily thick. Basically, whatever you set for the preferred height, that's the height of the rails and the thickness of the keyguard. So here are various items in the grid layout region of the keyguard. And if you just look at the screenshot, we already know from looking at the screenshot that this is a layout that is 4 columns by 3 rows. The default settings, I can't remember whether it's a 4 or a 3, but there's a default width. We're going to set the horizontal rail width to 3 for now, and we'll talk here in a moment about what the implications of that may be. We'll set the rail slope at 75 degrees. That just creates a little bit more gentle slope down into the button below or the cell below, and that may help kind of guide the user's hand down into that space. We'll use rectangular openings for the rectangular openings in the grid, because that's basically the shape of the buttons in TouchChat. If it were something other than rectangular, well then maybe this corner radius would start to play a role, but we'll take a look at that in a moment. As I said earlier, the TouchChat is laid out in such a way that everything is taking up as much space as possible, first of all, and everything is perfectly regular. But there are some apps where they're kind of off kilter, and the Keyguard is going to assume, unless you tell it specifically to account for it, that everything is laid out very regularly. And that your rails won't align with the edges of the buttons unless you manipulate the padding here. But fortunately, our spreadsheet will tell us what the padding should be. Also, it tells you the space, horizontal space and vertical space between the buttons. And you can think of that kind of as a minimum size of your rails. And truth is, you don't want zero width rails anyway. So that just means that in our, where are we at here? In TouchChat, there's no space between the buttons. Any rail you put in here is going to cover some space. I can't remember if TouchChat allows you to put space between buttons, but certainly in the layout I've picked, any width to my rail is going to cover part of the button. That can be problematic. You'd kind of like your rails to be as wide as possible. That means they're as strong as possible, but you don't want to start covering your graphic or covering words. So in a minute, you'll get to see, well, more than a minute, but in a while, you'll get to see what the options are there for controlling, for comparing the width and height of your rails to the actual screenshot. So let's see. I think I actually said some things here. All right. So let's do our little demo of putting in those values, which were, should I have them here somewhere? Here, I got them. Into the designer. Now we're in the grid layout region. Let's see. Do you recommend turning the Keyguard insert? Do I recommend turning on the Keyguard insert setting in TouchChat so I have some space between buttons? You know, that's really the SLP's decision. And that's because you know better than anyone else what the mobility and accuracy of your user is. If you make the buttons too small, because you're trying to account for the Keyguard, well, then you've made the app inaccessible anyway. I'll just say that a 3mm wide rail is a very strong rail. You start going 2mm and it can be a little less strong also. Again, things are based on the width of the base. So the overall thickness of the Keyguard is going to be a function somewhat of the width of the base and the angle of those slopes. So the thinner you go, the less thick the Keyguard can be. But I hate to make recommendations on settings in an app when you really know best what your student or client can tolerate and still get what they need out of the app. All right, so let's put values in to the designer. We're four columns, 3 rows, and our horizontal, we're going to take these down to 3. And again, that's still very strong. Our preferred rail height, I might want it to be thicker, but trigonometry is going to limit me to how tall these rails can be and therefore how thick the Keyguard can be. If I need this to be taller, well, then first thing I'm going to have to do is increase the rail slope or increase the width. So I'm going to increase the rail slope here to 75. And I can actually bring this, I'm going to bring the preferred rail height down from 5 to 4. You know, this is just what seems to feel right to you. I kind of like this because it puts a little flat top on this instead of having it be a point. So that flattens off the top a little bit. And yeah, so I've set pretty much everything here. The shape of the opening is rectangular, but depending on the app, you could make it a rounded rectangle. You could change the corner radius of it. If you wanted, I think they're termed touch guides, you can give it a circular opening and you can make the what controls the size of circles is what you set as rail width. So you can make these circles really small by just setting horizontal and vertical rail width. The horizontal one's going to be the important thing here. So you can make these circles pretty small if you want. We're going to leave it rectangular with a 3. And rectangular. Okay, so that covers this section for now. Does rounded rectangle help to make the intersection of the vertical and horizontal stronger? I would say it does. It does, and if you found that your Keyguards were cracking at one of these intersections, then you could try using a rounded rectangle there. As you can see from the layout here, other than these indicators that there's more, rounding these corners doesn't lose you much. But that's, again, I will say that I would feel comfortable just staying with the shape of the button until I found I had a problem. And the Keyguard wasn't as strong as I'd wanted. But there, like I say, there are other ways you can address that as well, just by making your rails wider, making the Keyguard thicker. But they're pretty strong, pretty strong. All right. All right, so are we done? Well, not quite. We're not quite done because there are several things we still need. This is where we are right now. That's what our Keyguard looks like. We need to first of all create an opening for the vocab button. We need to stick this edge out further to fill in the entire the cutout that's in the case. So we're fully covering the home button. Whoops, backward. And we need to etch the word workshop onto the back of the Keyguard. So we're about 13 or so minutes from a break right now. Hope you're all still hanging in there. Just to show you progress on the Keyguard itself. There it is. We're into the honeycomb region of the Keyguard. 3D prints aren't completely filled in with plastic. That'd be a real waste of plastic. They don't need it. So just the bottom layers and the top layers are solid, while the middle layers are usually this honeycomb kind of pattern. All right, so let's talk about what's going to be a hybrid Keyguard, because we're going to put an arbitrary opening into this Keyguard. We're going to add to it, and we're going to do some engraving. As I just said, ours is actually a hybrid. It has a rectangular cut in the command bar. It has a small rounded rectangle added to the perimeter to cover the home button, or actually half a rounded rectangle. And we're going to put the ID of the Keyguard on the back surface through some engraving. And engraving is a euphemism here. I'm not sure if that's the right word. The truth is, you don't engrave when you're 3D printing. You simply don't put plastic there. And all the instructions for these cuts and additions are going to go into various info files. Now we're going to need to talk about some terminology here. We have 3 different info files, and how we fill them, it depends on what part of our Keyguard we're talking about, and what part of the screen we're talking about. So the first piece of terminology I want to talk about here is the screen. What are we calling the screen? So the screen is that part of the tablet that lights up when you turn on the tablet. It's also the collection of pixels that you capture when you take a screenshot. So the designer will let you determine the coordinates of your cut relative to the upper left or lower left of the screen. It'll also let you make your measurements in pixels using a graphics program, or in millimeters if you used a metric ruler. We're going to use pixels because we're going to be using Microsoft Paint in our screenshot to get these measurements. So you're going to tell the designer what your choices are. You're going to do that in the designer itself. Let's see if I talk about, yes. You're going to set these last 2 options for the unit of measure and the starting corner. There's a Freeform and hybrid Keyguard opening section in the customizer for that purpose. Let me point it out to you real quick here. It's the grid. So here is the Freeform and hybrid Keyguard opening section. Skip this for right now, and we'll talk about, yes, we're going to use pixels, and our measurements are going to come from the upper left corner on out. Like I said, that's what Microsoft Paint assumes. I should have mentioned earlier that our designer, the spreadsheet assumes that all measurements are coming from the upper left corner. If you happen to be using a graphics program that doesn't start 0, 0 in the upper left, just let us know and we'll design a new spreadsheet for you that does take that into account. So we want to expose this vocab button here. And this is a piece of the screenshot that shows that part of the screen. So remember that Microsoft Paint sets that 0, 0 location in the upper left, and that X increases as you move down. Well, Y increases as you move from left to, I'm sorry, that's backwards. X increases as you move from left to right, and Y increases as you move down the screen. So let's plan to make a rectangular cut right over the vocab button. And you're going to specify this cut in this way. The designer requires 4 measurements, in order to cut an arbitrary rectangular opening in the keyguard. It needs the height, the width, and the coordinates X and Y of the lower left corner of that cut. And if we move our cursor in Microsoft Paint to this lower left corner, it's going to say that the coordinates there are X equals 0 and Y equals 95. And then to determine the overall height and width, I just need to also know the coordinates of the upper left-hand corner. So it gets a little crazy here because Y increases as you move down. So the Y value is larger here than it is here. Then with just a little bit of math, we know that we have all the information we need. We know the X location is 0, Y is 95, the height, that's that 95 for the Y minus 57 for the Y, a total of 38. The width is 80 minus 0, 80, and the shape is going to be an R. Because that cut is falling within the screen region of the case opening of the keyguard, we'll put that information, that instruction, we'll put that in screenopenings.info. We pointed that out earlier. We have a file called screenopenings.info. So we're going to put that instruction in there. And you can edit this file. I'll just bring it up right now. You can edit this file with Notepad, and text edit on a Mac. Just make sure you're not using any super fancy editor because they tend to put special characters in your file. And we want this to be as vanilla as possible. Okay, we're getting closer to the break. So at the top of the file are just some instructions, some information about what goes in various columns later on. But those all have these double slashes in the front. That just tells the designer, ignore these lines. They're just there for you to read. Where the actual magic happens is down at the bottom here. And I've got that blown up on the slide. So the designer is going to ignore any lines that start with a double slash. And each one of these data lines start and end with square brackets. And each should have a comma at the end, except for the last one. You just want to keep that in mind. And these columns, they're just for your benefit. They don't mean anything special to the designer. Designer only cares about things like brackets and commas and commas. All this white space in between is just for your benefit so you can see that certain things align and therefore this value must be the width rather than something else. So let's take a look here next. Okay, we're going to open screenopenings.info. So we're going to go ahead and make some changes that we determined earlier from our measurements. We're going to add these values, the X location, the Y location, the height and width, and the value R for the shape. We're also going to get rid of these double slashes in the front and at the end, and we're going to get rid of the comma there. Remember that these lines, because they have the double slashes, are ignored. So all we have is one data line. You need to delete that comma. And this is fun because every time you make a change to this file and save it, the designer is looking for changes. So every time you save it, and in the easy way to do that in Notepad is type Control S. We're going to see the screen actually update as we do this. So let's make those changes in reality and see what happens. So we're not going to use the designer at this point, but I'm going to use it because I want to see when things happen. Specifically, we're looking for a cut up here over the vocab button. So we'll bring up that file again. And first thing we'll do is we'll get rid of these slashes by deleting them. And we'll delete that extra comma there so our columns line up visually better. We'll get rid of this comma at the end. Now this is a data line ready to go. It doesn't do anything interesting because its X location is 0, Y location is 0, height and width is 0. It's not really doing anything. But let's go ahead and change those values. The Y was 95. The width, next the width is 80. If I just sweep out a space there, things will still continue to be aligned. The height is 838. And the shape is an R for rectangle. Okay, so we're going to keep an eye up here. I'm just going to type Control S to say save this file. And I hope you saw how quickly that happens. The designer went out, saw this, ooh, look, somebody's made a change. How does that affect my design? And now we have this nice rectangular cut here. Almost like magic. So this corner here just looks visibly pointy. And since we should always be looking for ways to make our key guards more safe, let's round this corner a little bit. So there's just less chance of it getting caught on something. So there are lots of cuts that we can make to the key guard. This is the corner that we'd like to round off right here. And we're going to use something called an outer arc to do that. And there are 4 possible outer arcs that the designer supports. We're going to be using outer arc number 4. To place an outer arc, you need to specify the coordinates of the point that you're rounding off. That's this XY location. And you need to specify the radius of the cut. So since we already know from measurements we took earlier that the XY location here of this point we're trying to round off is 80 and 57, we got that in the screenshot. We pretty much know what we need to put in there into the info file. We know we're using, the shape is an OA4, that the X is 80, the Y is 57. And the corner radius is, well, I don't know. I think and this is again the beauty of being able to instantaneously see your changes to the info files, that we're just going to try some different values and see what they look like. The one thing to keep in mind is we've told the designer that our measurements are in pixels, and pixels are really tiny. So don't be surprised that we put in what seems to be a large value for the corner radius just to get a small cut, a small rounding of the corner. All right, so we're going to enter this data in. We already knew this part, 80, 57. We ignore the width and the height because they have no relevance to this kind of a cut. We're going to put an OA4 in the shape column. And we're going to, this is probably where we're going to end up because it must be where I ended up when I came up with the slide deck. Well, we have to remember to put a comma back in after the first line because only the last line has no comma. And then once we're done, we'll type Control S again just to see our changes. So let's do that. Let's see so we'll bring up screen openings again and bring up the designer. Let's move you up. All right. We wanted to put, now first we want to get rid of our slashes in the front and at the end so the designer doesn't, or at the front so it doesn't ignore us. Put a comma in after this row. Take the comma in out of that row rather. Our X location is 80. The Y location is 57. And the shape is an OA4. Can delete some of these spaces just to get us lined up a little bit better. And the last thing we're going to worry about here is the corner radius. And I'm just going to, let's put a 5 in here just to see what happens. And type Control S. Okay, so that probably was really hard to see because we put a tiny little curve on here. So that's going to be too small. Let's make it bigger. Let's try 10. Control S again. Oh, that's looking way better. We could go bigger yet. I'm not sure we're gaining anything. Put a 20 in there. Okay. I think when I came up with my final one, I used just a 10 here. This is, you know, in the eye of the beholder, what's the right value here? You know you don't want it to be pointy. Sorry, I'm used to pressing A and Enter to get things done, but I need to do Control S. So we just want to take that point and get rid of the point. So 10 did that for us. Okay, so we're making progress toward the end. And look. Okay, it looks much better. Again, you may have wanted a larger radius here. That's totally up to you. All right, so more terminology here because now we're going to be working in a part of the Keyguard that's not directly over the screen. So when you measured the case opening, you defined the case region of the tablet. Features in the case region are located relative to the lower left corner of the case. And all measurements are done in millimeters only. Now that may seem kind of arbitrary here, but remember now we're no longer using a screenshot to locate things. And so the whole idea of using pixel measurements and upper left-hand corner as the starting location, that really kind of is no longer relevant. So we're just going to use a straight old ruler, a metric ruler to make measurements relative to this corner of the case opening. And like everything else, all measurements will be in millimeters. So we're going to engrave the word workshop. That's the ID for this Keyguard on the underside. That's why it looks weird here. It's kind of written backwards because you're looking through the Keyguard to see that. And because that cut or that engraving will go in the case region rather than the screen region, we're going to put our instructions in caseopenings.info. So we can control the direction of the text by what number we put in the top slope column. In this instance, we're going to simply be going with the standard direction like this. So we'll be putting a 0 there in this column. But depending on where you wanted to put the text, you might want it to go in different orientations. So we're going to need to specify the coordinates of the lower left corner of the text, and that includes any descenders, so this lower part of the G. So X and Y location of this sort of bounding rectangle, and we specify the height as well of the text. I wouldn't think of it as point size, it's something else. It's actually physical height in millimeters. So the shape in this instance is going to be B text. If it were going on top of the keyguard, we'd use T text as the shape, but it's going on the bottom or underside of the keyguard. So we're going to use B text as the shape. We can control the slope is the direction. We're going to put a 0 there, top slope. The bottom slope, and if you are interested after the workshop, there's a reason why these sort of weird names are being used here for things that have nothing to do with slope. But the font style is going in bottom slope. And we're going to put a 1 in there we want a bold font style. So here's what we put in caseopenings.info. And now remember that we're entering values in millimeters. So what looked like a large number for that curve is going to produce a very large bit of text if we're not careful, because we're no longer in pixels, now we're in millimeters. Positioning text on the back of a keyguard is really challenging. It kind of makes you think, kind of like trying to work on something through a mirror. But so we're not going to really think too hard about the values we actually put in here to these various columns. We're just going to just try some things and see what happens. Now, because we're engraving the text, the fact that we have a bunch of button openings can make it really hard to see our engraved text. It may be appearing over the top of or in the space of one of those openings, and we just won't see it. So there's a little trick we can do temporarily. We're going to temporarily set the number of columns, or we can do this with the number of rows as well, to 0. And then the keyguard becomes a solid slab of plastic, and the text will be easier to see, especially in the beginning when we're not quite sure where that text is going to show up. So this is what we're going to put in case openings. We're going to put a starting X location, a starting Y location, a starting height, and these other values as well, just to see where it appears, and then we'll adjust to get what we want. All right, so let's do that. We're done with screen openings. Let's now put some content in case openings. Looks a lot like screen openings here at the bottom. Had a region of supporting text at the top that the designer is ignoring. And I'm going to kind of turn the designer upside down. It's kind of hard to do this with OpenSCAD. It doesn't happen nicely, but there it is. We're looking at the underside of the keyguard right now. And we want our text to appear. Let's see, that's the funny part. When I'm looking at it from the front, this is the 0, 0 location right here. So as I turn it over, this is the 0, 0 location. It's not over here. So this is, again, the part that's hard to kind of wrap your mind around. This is the 0, 0 location. And I'm going to temporarily set my number of columns to 0. So that just filled everything in, except for a cut we're making in screenopenings.info. We want to put the word workshop right down here. So let's start by getting rid of these slashes in front so that the designer sees this line and the comma at the end, because only one line can have, or only the last line should not have a comma. All right, the shape is B text. And slide this over a bit so I can more easily see columns. The X location, I'm going to I want that word workshop to entirely appear on this. So I'm going to have to push it in the X direction a ways. I'm just going to put a 50 here just to see. This is 50 millimeters. And the Y location, that's the bottom of the descender. You know what happens? We'll leave it at 0. We'll see what happens. The height, I'm going to say, is a 10. Let's say 10. What the heck? 10 for now. And the word workshop is going to go in the other column. We're going to have to put it in quotes. So the designer knows where the characters start and end. What else do I need to do? I need to set the bottom slope to 1 because we want bold text. And the top slope has to be 0 because we want it to be horizontal text. So we'll just get rid of that. Okay, so cross your fingers and let's type Control S. Okay, so something happened here. It's a little hard to see because of the angle of the keyguard. So there's the word workshop. So clearly we need to set the X value even larger, and what I'm going to recommend here is let's start by making the height smaller because I know there's not that much actual plastic down there at the bottom. So we'll say 5 instead and Control S. Okay, so now we see it better. The P is kind of running off the edge of the keyguard. So let's put you up a couple, 2 millimeters. Let's see. And Control S. You see how what I said, what I'm talking about? Well, bottom slope is 1, not 91. You're right, 91. Yeah, I'm not, you know what I think it's doing in that case? Thank you very much, Christy. It's just saying, I don't know what that is. I'm just going with the default, which is plain text. So with bold text, we look like that. Thanks, Christy. And I don't want it to be this far in. Let's move it back a little bit. So we'll take this value to 40 maybe. And Control S. Okay, so this is pretty close to what I want. Now I said that we go with a height of 5, assuming that I had enough space here. I won't know that till I take my grid value, the number of columns, back up to 4. Ooh, we got lucky. So it fits. I could also center it more by making this Y value a 1 so it's not pushed up as high. Done. And this is really kind of how you have to place text, especially on the underside. You got to play with it a lot to get kind of what you want. But that's good. We're ready to go with that step of the requirements. So we can move on with the presentation. So most cases have a rectangular opening, and even if the corners are curved, the opening is basically rectangular, but sometimes they're not. And accent systems are a really well-known example of this. So if your case opening isn't rectangular, you can add plastic to the outside of your design so that it more completely fits that opening. And these instructions are going to go into the case additions part of the info file, because it's talking strictly about the outer perimeter. So the designer supports adding many different shapes to that outside, so it can handle a fairly complex perimeter. As I said, this is an Accent 1400 system with a system that, or a case that comes from the manufacturer, and it has some really interesting shapes on the outside, including just bulges that stick out from the sides, but then these little things. And it's possible, let me show you that it's actually possible to add all of that to your Keyguard if you want to cover it. So this is the Keyguard I made to go in that case. It's actually rather large and has another feature we'll talk about in a minute. But you can add all those shapes to the outside and fill in the entire space. It's been beat on a bit by me. That's why it looks a little broken here. So our example just needs more plastic added to the left side of the case opening so it can completely cover that home button. That's that opening we're talking about right here. Has that small cutout on the left. And if we leave any part of it exposed, then part of the home button is exposed, but we want to cover that entire home button. So the plastic will be 4 millimeters wide and 36 millimeters long. And it's the center of that piece is 62 millimeters from the lower left corner of the case opening. And the case additions file, just like the case openings file, assumes that all measurements are in millimeters and that they're taken from the lower left corner of the case opening. Let me point out just from this part of this screenshot here, that, or the photo, that the left part of the case opening is actually right here. So it's as if the case were completely rectangular. So we're ignoring the fact that there's a little bit of rubbery stuff here that makes that provides a radius to the opening. It's right here is the 0, 0 location for the case opening. So we're going to use a rounded rectangle, actually a half of a rounded rectangle, to fill this space. We'll need to specify the width, the height, and this center point, which you see we've already got. So in this example, we're going to use an RR rounded rectangle number 4 to do it. The data is mostly known at this point based on the measurements that were taken. We want the X is going to be 0 because it's right up against this side of the case opening. The Y is 62. The width is 4 and the height is 36. The corner radius, we'll play with it a bit. It'll not be particularly easy to see since we can't compare it visually to the actual case. But our shape will be an RR44. RR4, sorry. All right, so this is what it looks like. This is what we're going to try to add to the case additions info file, and we're going to see how the design looks each time we save the file. First, let's get our Keyguard right side up again. Zoom out a bit. So this is where we're going to put that rounded rectangle. And we'll bring up the case additions info file. Again, looks very much the same at the top, a lot of instructions. It's a little bit different in what the columns are because it's doing very different things than cuts and engraving and embossing. So let's see, we want to start by get rid of the double slashes. We'll get rid of the comma. All these things still apply. The X is 0, which it still is. The Y is 62. The width, we measured that at 4 millimeters. The height is 36. The shape is let's see, I can just leave that R and type another R, R4. And the corner radius, let's just play with it. It's not going to be easy again. We don't have a physical case in this picture to compare it to, but let's say we want it to be 8 and Control S. There it is. So again, it appeared pretty quickly. I'm holding this case up for myself, and that's a little bit much. Let's take it down a bit. Let's call it a 6. Control S. And there it is. A little bit less. Even that looks a bit much. I think I'm going to take it down to 4. Control S. Okay, it's not perfect because it's not a purely rounded rectangle in the case, but all we're really trying to do is fit the cases as nicely as we can, and that should do it. So we can close this guy now. So we've done a lot of the shaping that we expect here, but it's hard to know at this point how well the final Keyguard is going to fit the actual app based on what we've done so far. So let's explore a way for us to compare the fit to the app without actually printing the Keyguard. So you can use your screenshot to do this test. And the first thing you have to do is convert your screenshot from a JPEG or a PNG file into an SVG file. We're going to use Inkscape, which is also free, open source. I think it's open source. It's definitely free program to do this. You can download it, the link right there, provided on slide. And we're going to compare the converted screenshot. We're going to place it behind our Keyguard and see how things fit. So let's try this. And I'll take you through the process for doing that. So we have Inkscape loaded already. It's a slow program to load. That's why I've loaded it already. And here's our screenshot. So we're going to drag it and we're going to drop it on Inkscape. Now what Inkscape's going to ask me is some information I am not going to even research. I'm just going to say, okay, do it. So now my image is now inside Inkscape. It's a bitmappy kind of thing. So Inkscape's going to want to convert that first to something that is more SVG-like. And you do that by choosing from the path menu, you choose Trace Bitmap. And I'll make it wider again here. So it wants help from you to decide how it should make decisions about what to pay attention to. And it's going to do that by you telling it how bright the images or whatever should be for it to pay attention to. We're just trying to look for something that roughly shows all of these boundaries. And so I'm going to just try what it is right now. I'm going to say update, and it'll show me a little picture here. especially if we make this full screen. It'll show me a little picture here of what it is seeing. So it's nice, except it's missing some things. It's missing the entire command bar. And I can pick that up by just increasing the brightness threshold a bit and updating. Oh, okay. Well, that's already pretty good, isn't it? I'm seeing everything I really want to see. I want to see the full command bar, the message bar, the borders between the buttons, and even some aspects of the buttons. I'm just going to stop here because that worked pretty well and say apply. So it's hard to tell by looking at this, but there are two images here overlapping each other directly, and I can just drag one away so that they're separate. I want the black and white one. I don't want this one that's in color. So I'm going to select it and press the delete button to delete it. The last thing I do is I have to make sure that when it saves this as an SVG file, it knows exactly the boundaries of what to save. So I will choose, by the way, all this is on the web page associated with doing this conversion. So you don't have to remember these steps all that well. But I'll choose from the edit menu, resize page to selection. So now what it saves is everything within this bounding box. I'll save it. I want to put it in the same folder as the Keyguard.scad program. And I want to give it the name screenshot. That's important. So it'll be screenshot.svg. Save. And that's already done. So now I look here and there is a Inkscape style file called screenshot.svg. Next, I'm going to bring up the designer and in this section called Special Actions and Settings, I'm going to say, I've got a screenshot, please include it. Yes. Takes a little while to render it, and there it is. One thing I'll point out here is this is a lot for OpenSCAD to kind of manage, so it'll be a little slower when you're dealing with it and showing the screenshot at the same time. So there was a question that came earlier about, well, what if we had thicker or thinner rails? This is a good way to test that. Right now our rails they're 3 millimeters wide, and 3 millimeters for they're vertical rails and horizontal rails. The vertical rails are 3 millimeters wide, the horizontal rails are 3 millimeters wide. But let's say I wanted to make the horizontal rails thicker. I can. I'll just say, let's make them 6. Now they're thicker, and I can see, well, what would this is roughly what it will do to the access to the graphics below. That's a bit much. 4, better, but still I'm not comfortable with it covering part of this graphic here. So I'll leave those at 3. It's also a good way to realize after the fact that you have one of these columns, one of these values wrong. Oh, that's obviously wrong. And you look back at your screenshot, you say, oh wait, that should have been a 4. So it's a good way to check your work. All right, so the one thing I'd say is before we move any further, we need to make sure that we have hidden that screenshot, because if we say go ahead and turn this into a 3D print, it'll actually print all that. You don't want that. It's not that one. Include screenshot goes to no, and our tablet is back where we wanted. We like the layout as is. We wouldn't change it right now until something else drove us to change it. Like it was breaking too easily, for example. And then we'd say, well, can we do some other things here to make it stronger? Okay, so the next thing would be how well does this, we have a sense now of how well it's going to fit the app, but do we have a sense of how well it's going to fit the case? Since there's no good way to get the image of the case into the same, into the designer. So it's always smart to print the first few layers of your Keyguard and then check the fit before printing the entire Keyguard. And the designer supports you in doing that. If you print just the first 2 layers, you get something that's still fairly rigid and strong. And you can easily compare that right to your physical case. So it turns out I've already done this. And by the way, again, you set the first 2 layers only to yes. And then when you go through the process of creating your STL file and printing it, you'll only get the first 2 layers if you print 2.2 millimeter layer heights. But that's what most people are going to do anyway. So just the first 2 layers. So let's show you what that looks like in real life. So this is a little mask. It's a little less than 0.5 millimeter thick. It's 2 layers of printing. And I can compare this now right to my case and tablet. See what the fit looks like. That's right, it's the other way around. And what I'm seeing is a really nice fit inside the case opening. Some parts of the word workshop are missing, and that's just because they're internal parts of the O and the P, and when I took it off the build plate, this thickness, those remain behind. There was nothing to join them yet. I can turn the app on. And look at the fit to the actual app, and it's pretty close to what we saw just by comparing an SVG file to it. Remember this thing here for later when we talk about laser cut and ways to limit your exposure to that process. Okay, so first 2 layers only was the way to make that happen, and then go through the process of preparing it for printing and printing. Okay, now we're almost done, but we need to decide how we're going to attach the Keyguard to the tablet and to the case. So this table here that's on that same web page, the main web page, shows all the mounting methods you can choose among for your Keyguard. The table attempts to describe characteristics for each of the methods. And note that there are 3 methods here that can't be used with a case, these 3. So they have no X in this column. So we're going to ignore those 3 methods. You know, and it's no big loss because primarily tablets are almost always used with a case in this world. And another reason is because microsuction tape, we're going to talk about that in a moment, holds better than all these methods anyway. So this is what clip-on straps look like. They involve a set of 3D printed clips that snap into grooves on the top of the Keyguard. And you're probably already familiar with slide-in tabs because that's what you're typically going to see on a laser cut Keyguard. And lastly, these are raised tabs. We'll show you live versions of these in a moment. They attach to the top surface of the case. And they don't, rather than sliding under the edge of the case, they attach to the top surface of the case opening. So let's see what they look like in real life. First, we talked about some clip-on straps. These are the clips. They're printed as well, just like the Keyguard is printed. They're 3D printed, and the way they work is there is a little groove created in the Keyguard top. And let me see here. So you slide the clip over the edge and it snaps into the clip, into the groove, rather. You can do that on any number of sides, including the top. And if you have somebody who's really interested in working on trying to take the Keyguard off, these will foil them. You can also run a strap between them. I guess there's nothing to run this one to, but you can run straps between them on the back to hold them in place if they're not already sufficiently being held. And rubbery cases like this hold these clips well enough without the strap. Here's your slide-in tabs. You can create those with the designer as well. Take a view here from the angle. Slip underneath the side of the case. Maybe if you have a screen protector, that's just not going to work. And lastly, these are the raised tabs, and they sit on the top surface of the case. They're usually held on with Velcro. And they may just be about your only option if you have a screen protector that doesn't give you any way to slide a slide-in tab, that provides you only tiny little bits of space between the case opening and the edge of the screen. These may be your best option. All right, so then the last category is a strange thing called no mount. It just means that nothing special is included in the design for this method. There's no special printing done for this method. Instead, the Keyguard is simply squeezed into place or attached with microsuction tape. So let's go live. Let's see an example of this. So here is our Keyguard, pre-printed, just like on all the cooking shows. And on the underside is microsuction tape. It's an odd name to call it only because, well, the tape part is odd because it comes in a sheet. And it's a very thin sheet. This one, the ones I like are 0.5 millimeter thick. That means that when you finally attach this to your tablet, the Keyguard is sitting almost flush with the screen. There's no big gap between the Keyguard and the glass. The back of the tape, for lack of a better term, there's an adhesive there, and that goes against the Keyguard. Then on the front, and there's just a light film covering it when it's in sheet form. I'm going to lie a little bit here and say that the surface has a number of tiny little suction cups. It's not really that at all, but it behaves exactly the same way as if it had tiny little suction cups. It's held in it's held to the glass by a vacuum. So you just press it in place and it stays attached really well. It can even be tough to pull off because it's being held in place by suction. The more tape you put on, the harder it holds. This is already bordering on too much, depending on how much stick you want. And as you can see, there's no residue left behind because it's not an adhesive. It's being held in place by suction. So how do you choose a mounting method? Well, as you saw in the previous slides, there are some no case versions, but nobody has that. So you can basically ignore these three methods. All of them can be replaced with microsuction tape, and that works really well, better than all of these methods. And then we have a series of options that are for cases. Each is going to have its own strengths and potentially weaknesses. The first one is the no mount method, where you just wedge it into place by making your keyguard just a hair larger than the case opening. Works really well with rubbery cases. And a student who's not too focused on pulling the keyguard off. To use microsuction tape, you have to have some pieces of plastic on the underside of the keyguard that are wide enough to put the tape on. Clip-on straps, they require that there be enough plastic around the edge for there to be a place for the clip to snap into. But once they're in place, they're really hard for students to remove. Slide-in tabs, they're good for rubbery cases that don't have a screen protector. As soon as you have a screen protector, it tends to damage the screen protector by sliding these little tabs underneath the edge. And they're difficult for a student to remove, but that means they can be tough for the instructor to remove as well if you're swapping keyguards rapidly or often. And there's the raised tabs, and they can save the day when you have a screen protector if it's real close to the active region of the screen and no extra plastic for putting microsuction tape on. Our winner for this keyguard is the no mount mount. We're just going to use microsuction tape, and it's my favorite in any situation where you can use it. Okay, so no mount is the default mounting method. We don't need to do anything to add that to our design, so we're actually finally ready to save our design and prepare it to be printed. First thing we're going to do is save our options, all those values that we set for our design in the form of a preset. And that can be really helpful if we need to come back and change something or create another keyguard that's very similar. And then we will render the design. Just means the program turns it into something that has a full exterior shape. And let me go back one. Let me point out this point. This can happen really quickly or take several minutes depending on the speed of your computer and the complexity of your keyguard. So if you are ever going to feel the need to upgrade your computer, you're going to feel it at this step. And then we'll export the design as an STL file. Excuse me. The designer will try to give it a generic name. Hang on for a sec. I'll get a drink. Try to give it a generic name. Just make sure you change the name before you save it to the same name that you wanted it to have as an ID for your keyguard. And so we use the word workshop. Okay. And then if you remember right, our keyguard magically started out as an STL file in this workshop. So we're actually getting back to where we started. And let's see what that process looks like. All right, so I said the first thing we want to do is we want to save this as a preset. That means press this plus button to add a new preset. And we're going to call it Workshop. That means we have all of those options that are in this customizer region saved. And we don't have to go back and reimagine what they were. Then we're going to go to the design menu and choose render. Keep an eye on this little green bar at the bottom of the screen as it progresses through the rendering process. And it's done. The word workshop still on the back. Easier to see now, actually, because it's different in color, differences in color. And finally, we'll save it by exporting it. There are lots of options for how you export what you've got here. We're going to export it as an STL file. And again, this I told you is try to give it a generic name. We're going to give it the name Workshop. All right, so that's done. And if we look at our folder, we now have a new file called workshop.stl. It's what I dragged and dropped on the slicer earlier and how we began the workshop. So we're not done yet with our workshop or the Keyguard. It's still printing. It's getting up to the top. It's going to start printing some solid layers to finish off the Keyguard. But I want to point out to you there are lots of fun things we can do with the designer here that don't require that we put anything special in an info file, but they're just options to choose from pull downs in the customizer region of the designer. So we're going to look at each one of these in turn on the following slides. First, there's a thing called an unbalanced case. So up until now, we've assumed that the screen is sitting directly in the center of the case. And so it's this border on the left and the border on the right are the same width, same with top and bottom borders. That's safe because most of the time it's true. So the designer just assumes that. However, there are instances where cases are designed to be unbalanced. And this life-proof case is an example. Other examples are cases that are just made poorly or stretched out of shape over time, which allows the tablet to slide around within the case, and that's what's happening in our case. We have a cheap rubbery case, and turns out that the tablet slides around inside. Well, the designer allows you to accommodate for those two issues with two options in the special actions and settings section called unequal left side and unequal bottom side. If you just leave those values at 0, which is their default, then you're cool, you're okay to go. It means that the screen is sitting exactly in the middle. You have no problem. And if it's not, then you just measure the side that's out of balance, the left side or the bottom side, and type the value of that measurement into one of these boxes or both, depending on how bad the case is. So here's that life-proof case. It has a much larger border on the top than it does on the bottom. So in order to get the grid to fit properly over the openings, you have to tell the designer that it has an unequal bottom side of case opening, and you simply enter the distance from the edge of the case opening to the edge of the screen and put that in the unequal bottom side field or box. Here's our case. And I don't know if you noticed it. I didn't notice it till after I'd already printed one, a Keyguard. But this side here is smaller than this side over here. I discovered that because my rails didn't line up. And after some examination, I could tell why. First of all, it doesn't fit tightly from side to side. It does pretty well from top to bottom, but side to side, it does not fit tightly. And when you're putting the power cable in to the jack on the tablet, you're pushing it in from this side, which forces the tablet to slide this way. Now, once we get our Keyguard made and sticking to the tablet and fitting nicely within this case opening, that's not going to matter anymore because the Keyguard will, in effect, hold the tablet in place within the case opening. But I had to adjust for that, and I actually already have in the Keyguard that's printing. So I just measure this distance. It's 14 millimeters, and I enter that value up here. And that slid everything this way from right to left. It slid all the elements of the Keyguard from right to left in the design. Sometimes an app has a region that's larger than a button, but that region doesn't entirely cross the screen from side to side like a message bar or command bar. And other times you may want to hide a button so it doesn't distract the user. So here's the Snap Core First app. And it has a message bar area up here at the top, but there are buttons on either side of it that look like they should be separated by some kind of rail from each other and from the message area. Now, if you look at this message bar as just 3 openings that are merged together, then you can think of this entire app as a 6x6 grid, which is a much simpler design than what we were talking about earlier. And then we just have to figure out how to merge these openings. You may also want to hide this keyboard button and this word forms button because they're just distractions for your user, and they're going to alter the layout of the screen if the student accidentally presses them. So why not cover them with plastic? Let's talk about a little background here before we actually do some of that and try it. So in order to merge and cover cells, you have to refer to those cells by their number. Numbers start in the lower left and then increase from left to right and from bottom to top. So you can refer to any one of these cells by its number. In the customizer part of our designer, you'll see a pair of square brackets. You just put the numbers of the cells you want to merge or cover between the brackets and separate them with commas. When you want to merge 2 cells, you simply specify the first cell, either if you're merging horizontally or vertically, and it will merge that cell and the cell next to it or above it. So let's watch this in action. Let's bring up our design here. And so our cells are numbered 1, 2, 3, 4, 5, 6, 7, 8, and so on. Let's pretend that these are the cells we want to merge in Snap Core First to make a message bar. So this is, what cell is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is cell 10. And if I say I want to merge starting with cell 10, that'll do this one and this one. Let's do that. We do that in the grid layout section. Let's merge horizontally, starting at cell 10. I'm going to squeeze a 10 in there between those brackets. and then hit enter. So that's all it took to merge those two cells. If I wanted to merge these two cells vertically, I would put one in there, right here, in the merge cells vertically starting at. Just have to work my cursor between the two. Cell 1, and enter. This works whether they're rectangular or whether they're circular or whether they're rounded rectangles. The designer accommodates all that. If I want to cover these two cells, or cover this cell and this cell, this is 2, 3, 4. Let's put a 2, 4 in the cover these cells. 2, 4, enter, and they're covered. One thing to bring to your attention, and this I think of as a bug in OpenSCAD, is I cannot simply go back and delete if I make a mistake and then press enter. It just continues to populate that cell, or that between the brackets. So I'm going to simply delete and put a 0 in there. There are no cells numbered 0. So that's just something to remember, that you can, what that did is it stopped this from merging. Put a 0 there. So just a little trick of the trade if you make a mistake. One of the significant advantages of using 3D printing over laser cutting is that your Keyguard can have raised elements. So these raised landmarks can be critical for visually impaired and blind individuals. This picture is a 3D printed version of the Keyguard for the LampWords for Life VI application. So there are 3 options in the grid section for adding ridges around specific cells. It follows the same kinds of requirements as the merging and covering. Cells are numbered from 1 in the lower left, and they increase from right to left and bottom to top. Just want you to notice that, that's too soon, that the white here is simply because I changed filament color. After the top surface of the Keyguard was printed, I changed the filament out and put white in instead. These little horizontal and vertical ridges that are on the outside here, they're actually created by putting instructions in the case openings info file for a ridge, horizontal versus vertical. So let's see what putting ridges around cells looks like in action. Oh, there's your contrasting colors, just by swapping filaments. All right, let me put a ridge around cell. I think this is, yeah, this is 9. Let me put a ridge around cell 9. So that's how easy it was to put that ridge there. And I have some control, especially if I increase my horizontal and vertical rail width here, to do things with thickening the rail. I can change its height. You may want to do this to really control access to cells. I can change its thickness. Just as easy as doing that, putting whatever cells you want into this box right here and separating with commas. And make sure that the brackets are still in place when you're done typing, or type new brackets if somehow they got deleted. Okay, so getting low on time. Our Keyguard's still not quite done. Let me say at this point that there are several additional concepts to go here, and if it's okay with Matt, I will continue to go through the deck fully and record. And if you absolutely have to leave at 5, well, then you can come back and watch the recording for those last bits. But
Of course, that's fine, Ken.
okay, thank you, Matt.
Yep.
All right, so I said earlier the case is critical to your Keyguard design, particular the case opening. But if the case wraps the screen really tightly, the Keyguard perimeter will naturally be very thin and have, and therefore the Keyguard itself will be very fragile. By the way, common with screen protectors. The AEC app may be able to make some room for you by changing the layout or size of the buttons to make more room. But if not, or if you need even more room than what the app can provide, or if it just will not work for your client to be making buttons smaller, the designer can help, but you can't get something without giving something. And in this case, what you're giving is you're giving some space up. So, like I said, this is often the problem with screen protectors. You can add some more plastic to each edge of your Keyguard and independently add to each edge. However, note that there's no way to do this without losing the same amount of space or the same amount of access to the screen on the outside edge. So you'll find these 4 options in Special Actions and Settings in the Customizer. And let's go ahead and watch them in action quickly here. So I'm going to go back and I just want to get back to pre-merging and pre-merging and rigifying things. Okay, so here's our Keyguard as it is now. I'm going to make the case opening tighter. So let's see. What did I decide on here? So let's say that my case opening was 120 by 160. So this is really thin. And in fact, what you see up here up top is very little plastic here holding the top part of the Keyguard onto the next part. You could print this, but if it's exposed to any kind of pressure, it's probably going to crack one of these locations. Thank you, Monique, for your comment. So we can help here. It looks like the top edge and the bottom edge are still just fine, but this right and left side, we're going to need to do something here so that the Keyguard's a little thicker on the right and the left. And as I said, there are settings in Special Actions and Settings here called Top Edge Compensation for Tight Cases, where we're okay on the top, we're okay on the bottom. It's the left and the right. So I'm just going to, let's put a 3 in here and see what happens. So this is a little wider. That's something really interesting there going on. We'll talk about it in a moment. And let's add 3 to our right side. So now we have thicker edges. Talk about this little piece up here in a moment. We have thicker edges, and that didn't come without a price. So the price was these 3 openings are now smaller on the right side, and these 3 openings are smaller on the left side. But at least I can print this Keyguard, and it's likely to be fairly strong. What's happening up here is we said that our special opening in screenopenings.info starts at just a few, well, it was actually at the 0 point, if I remember right. at the very edge of the screen. So the cut for these little openings here happens after adding this edge. So that cuts there. If you want to fix that, we're going to have to move the X location here over to the right in order to get more plastic. It's not terrible to do. You just go back to screenopenings.info and change the X value. But we'll lose a little access to the letter V in vocab. Okay, now splitting a keyguard. So if your keyguard needs to be 315 millimeters wide, because that's the case opening width, and your 3D printer can't print anything larger than 300 millimeters, well, what are you going to do? So there are very large 3D printers, but they are very expensive. You have the option of using a laser cut keyguard, but we already have talked about some of the limitations there, and it's going to cost you more no matter what. But it still might be your best choice for a very large keyguard that needs to be transparent, for example. However, the designer will support you in splitting your keyguard into two halves and printing one half at a time. And the options for this are also in the special actions and settings section of the customizer. And we'll take a look at a quick demo. So this guy back up. We'll go through the same step of getting rid of the changes we've made. What if I wanted to split this in half? And it's pretty small, so it's not an issue, but let's pretend it's big, really wide. So what I'm going to do is I can go down to special actions and settings, and I can say I want to print the first half of the keyguard. And the designer is pretty smart about where to split a grid-based keyguard like this. It's going to split it right along one of the rails. Now it's problematic here. Nothing connects these two parts, but it's at least as smart as it can be. So you can generate the first half. You can generate the second half and go through the process of rendering and printing. This kind of split is described as down here as a flat split line type. There's a fancier type, a little bit stronger type, that is dovetails. So here are dovetails. We zoom in. And if we look at the other half of the keyguard, that has dovetails to match that fit in those slots. There's no optimal size for a dovetail. That really depends on the size of your keyguard and especially the height of the opening. So the designer provides you with some options for approximate dovetail width, and it will use a little bit of rules of thumb beyond that to come up with the best location for the dovetails, but you have to tell it basically what you want. And so you can choose different widths, and it will make a guess. You can see that some widths just don't work well. So this particular option of approximately 7 millimeters leaves a little chunk of nothing hanging here and another one over here. If I take it all the way to 10, it looks a little bit better. There are no chunks. I don't even think the slicer will attempt to do this little chunk here. But what I'd really like to see, again, because these are not connected directly, this part of the keyguard is not directly connected with this. What I really want to see is there be a full dovetail intersection on this top part, not just two halves that kind of overlap each other. And I think if we go down to 3 millimeter widths, we'll get that. So we'll see that we now have a full dovetail in the middle and two hooks on either side of it. So this is going to retain the rigidity of this upper part better. Now it does have two little outlying pieces, but I can tell you from experience, the slicer ignores those because they're too small for it to deal with. So I would go through the process of rendering and saving each half of the keyguard here. We'll take a look at what this actually looks like when done. So here is the keyguard I printed that way. So it's got dovetails on both sides. They fit together. It has a complete kind of hook on one side and dovetail on the other. And what you do is you overlap them. And you push them together. And the best way to push them is with a pusher. And sometimes you didn't align them well, and I get a little broken one here. But anyway, I've done it 2 different colors so that you can see the dovetails better. Up here, I got a little bit of brokenness here. But I might still be able to work into that slot. But the top is holding well because, well, holding well. I still will want to glue this, especially that top part. So it just shows you there are options for very large keyguards. Here's one, very large. Can't see it because both halves have been done in the same color, so you can't see the joint very well, but there is a dovetail joint in there. And it'd be impossible for me to print this even on my largest printer. Maybe I should have been gentler with my joiner. Okay, so that's splitting keyguards. And then if you're here in this workshop, you very probably are doing many keyguards for yourself or for others. And there are some ways to manage multiple keyguard designs that are better than others. I certainly have had to do that myself in trying to support multiple people. So I put some thought into what you should consider to make your life easier. And it's all described on this page. That's really where I would have you go to read through what's described there. But you've really put a lot of work into this keyguard design, and it can give you a leg up when you need to create your next keyguard, maybe very similar, or you need to replace a keyguard that's been lost or broken if you're managing your designs. When you have a keyguard that fits the case and the app really well, the last thing you want to do is start over from scratch. So you can save all of your work and then quickly recreate your previous keyguard at a later time if you're saving that work in a thoughtful way. What's the best type of adhesive to use when splitting keyguards? I think PLA tends to really work well with super glue. So that would be my first recommendation. Depending on how tight I didn't point out here, but you have some control over how tight the joint is. And you can loosen that joint up a little bit so you don't produce the havoc that I did. But for tight joints, assuming you can get that regularity out of your printer, you may not need any glue at all. So when I showed you that really large one, there's no glue on that really large one, but I'd struggle to get it apart at this point. That's just the beauty of dovetails. Okay, let's see. So save your work in a way that makes it easy for you to recreate your design. And this page is really comprehensive. So I'm just going to, I think, just direct you there. But I will talk about organizing your work a bit. So we've just dealt with a lot of items in creating our example keyguard. But before we do talk about this, since some people may have to leave in a minute, I do want to show you our keyguard's finished. And let's take a look at it. I'm going to take it off the printer. That's the beauty of these Prusa printers, is I can just take this metal sheet off over here, and it's flex or spring steel. So I can just flex it like that and the keyguard comes loose. The word workshop is on the underside. We've got our cut at the top here, our little protrusion on the right. And let's put it on our tablet. It just dropped. There it is, in place. All I really need to do, and by the way, let's see, change the angle here so you can see I've got really good visual access to that message bar because of the slope. And I've still got access to the vocab button. But I've got no access to the home button, which is what I wanted. Oh, and it's really shiny. And I guess I didn't use enough plastic for it to show it going through all the colors. But there is a darker bronze on top than the gold underneath. So they're kind of slick in their look. This has a real shiny effect compared to some of the other PLAs. So if you have a student who's really be attracted to something that has this and be proud of it as part of their AAC device, then you have options like that when you're doing 3D printing. Not so much when you're doing laser cut, because there are very few color options for acrylic. Okay, so I'm sorry if we went long, but again, you can catch up on all the material I'm still yet to cover by listening to the recording. Okay, so back here, let's talk about organizing our work. So we have all of this information that we've put effort into. We have photos of the tablet, the case, the running app, screenshot, and maybe an SVG of the screenshot. It says described later, but the fact is we've just gone through that effort. That's that thing we put behind the keyguard to see how nicely it fit. Any info files that you've modified, the padding and bar size spreadsheet where you measured things and got the millimeter equivalents, the data form, especially if you're working with somebody else, the STL file that you generated. You're going to want to keep all that information. But you don't have to keep them with the Keyguard program because you'll be using this one Keyguard program with multiple Keyguards. But all the other stuff that you've put effort into or changed, keep that in a separate folder. When we saved that workshop, where is it out here? When we saved that file, when we saved the preset for workshop, let's see, it created this thing called Keyguard version whatever .json. So that actually got created when we saved the preset, and that's what holds all of our changes. That's actually my next bullet point here. When you create that preset, you save all those values from the customizer pane in this file. If you're creating multiple keyguards, this file will contain those presets for all of those designs. So I'd recommend you back up that file regularly. You don't want, if you lose that file, you lose all of your saved presets. If you download a new version of the designer, because it changes as new features are added, new tablets are added, or bugs are fixed, then the next version will be version 42. When you download it, just change the name of your JSON file to version 42, and it will work just like it did before. Quickly show you some stuff. I think I'll skip all the how you do it specifically kind of things in live demo, but this is a recent addition to the designer saying the AAC apps on tablets are fundamentally designed to be used by sighted individuals. Well, is there a way to use the Keyguard that you now know how to make your app accessible to someone who's blind or visually impaired, but still can read Braille? Well, since you've learned how to create your Keyguard for your app, You can use it to help these folks select the right app button. The designer supports you in creating little inserts with Braille on them that go into these openings, and they squeeze into place. The options for creating the Braille inserts, you do them one at a time. They're in this, the Braille inserts section. You can talk about where you want the Braille to appear on the insert, how large it should be. A value of 10 is standard size Braille. The one thing I'd point out is they're rectangular by nature, so you should make sure that your openings in your Keyguard design are also rectangular, and set the rail slope to 90. So you don't want any kind of gradual slope down into the to the tile or button on the app at this point. You want a nice straight edge so that the insert fits as tightly as possible. And again, all these things are described here. They print on their sides. You should print them on their sides. They'll show up like this in the designer. You should print them that way as well, because Braille that's printed on a vertical surface is much better Braille than any Braille printed on a horizontal surface. Your printer is fully capable of printing something like this, thin and tall. You may need to add, in the parlance of 3D printing, a little brim to it, but if you're not doing the printing yourself, someone else is, they will know to add that. But definitely you want to print it vertically. So we're going to leave grid-based behind and hybrid keyguards behind, because now we're going to talk about freeform keyguards. And fundamentally, a freeform keyguard is one that doesn't have a simple grid of openings. Either the openings are not arranged directly above each other, above and below each other, or they may be of different widths. You can do this by specifying the location of your openings, their shapes, and their sizes. Like we did with our, when we added the engraved text, always just start with in fact, in this case, you'll always start with rows and or columns set to 0, because rows and column values are only meaningful if you're doing a grid. If you're not doing a grid, and which you're not when you're doing freeform, just set those to 0 and leave them at 0. Now you've got a solid piece of plastic that you're going to put holes in. You're going to specify every single opening other than the home and camera button, which you can hide if you want, but you can also just leave those open, and the designer will take care of those. Note that for an entirely new type of key tablet, you may need to specify openings for the home button and camera as well, because they may not be in the typical place where the designer assumes that those kinds of things would go. And again, note that any keyguard could be modeled as a freeform keyguard, but that's just a lot more work than you otherwise would have to do. But save yourself some time. So look for patterns in the layout of where the openings will be. For example, are all the openings the same shape, rounded rectangles in this case? Are all of them, I call them keys in this case, but are all the buttons that you're trying to hit the same basic height and shape? So they're different widths, but all of these keys here are the same height. Do some of them or many of them have the same width? Well, once you've determined it for one, just keep reusing that size. Do they all share, or do many of them share the same Y value? For example, all of these keys have the same Y value, and these keys have the same Y value. It's different, but all of these guys share the same Y value, and same here. So lots of opportunities for reusing measurements. You don't have to keep taking every single measurement. Keep a written record of what you're doing. We're going to use, we won't do too much of the demo, but we'll show you the spreadsheet we use here to make calculations easier, because I have trouble with arithmetic. But keep a written record. and get help from a friend. It really helps if one person is measuring and the other person is recording those measurements. All of these, certainly in this example, all of these openings are going in screenopenings.info. And we'll take a look here. Oh, we'll go back here and just, let me see. This is a more lengthy description, so let me just show you some of the things that I used here. So here's our spreadsheet. It records for every key some indicator of what that key is. Its X location, its Y location. And because I'm exposing the composition window on this mail composition screen, I also have that large region exposed too. And I took a measurement at the lower left corner and the upper right corner, and that helped me determine the height and width of that opening. It's a rectangular opening while the rest are all rounded rectangles. So this is what the app looks like. And as I mentioned, you're just taking measurements here. You're taking a lower left-hand corner measurement here. You're determining the height of this, and then we're using that for all of these openings except for this one. The only thing that changes on all of these openings is the X location changes. So if you look in the spreadsheet, only the X changed for those, but the Y is the same. The width is the same. The height is the same. The backspace key turns out is a little smaller than the others. And you just repeat that process. Like we saw before, you can make a change. You can make a change to the screen openings.info file, put a line in there for, I can show you what that looks like when some changes have been made to it. That's before I started. So here I've actually got the first two rows of keys entered are openings for those keys. Oh, this is everybody. The names, I can use names. I don't have to use numbers, but if I use some sort of alphabetic name, I have to put it in quotes or the designer gets confused. But here's everybody, and I can show you that. Oh, I got to bring my info files across. It's got a keyboard. I'm just replacing it with the one I put all the work in. Changing its name so the designer will find it. Oh, still got an L in there somehow. In this case, because I'm changing file names, I'll just do this. Okay, so I've messed up something. Well, I may have to show that somehow after the fact. I've messed something up because I got some errors here. So we'll skip that for now and just say every one of those openings has its own line in the info file. And as you add them, you just do Control S and see how it's changing there are two periods in the file name. Why didn't Windows tell me that? It's nice to have lots of eyes on this. I guess that's exactly the problem. Back and refresh. Set the grid layout. 0. There it is. Thanks for catching that, Janelle. All right, so there's our Keyguard ready to go, ready to print. And it this is one reason why you definitely want to just print a few at a time and test it out, a few layers at a time and test it out. There's the final Keyguard, and it fits the app. This is on my iPad Air. Fits. And then you learn something after you've got everything ready to go, and then you learn, if I put the cursor there, it changes the layout of the keys. And that's a pain. I don't know why they do that, but it helps to give some thought again to how many different layouts you're going to encounter in the use of an app, so that you're able to either easily replace a Keyguard or swap out Keyguard, or somehow accommodate multiple layouts with just one Keyguard, because it's it's a static thing. It can't change on its own. All right, now, cool part, if you haven't been cool yet. When a laser cut, the question is, when is a laser cut Keyguard the right thing for you? Because sometimes it is the right answer. 3D printed is not. So the first thing is, if you need a transparent Keyguard, which I'm finding fewer and fewer people actually do need, it's just what they're used to, you can't do that with 3D printing. Even if you have what's called a transparent filament, when you 3D print with it, you get a translucent result. And it's not even that translucent. You can see some colors through it, but that's about it. You may need a really large Keyguard that has to be a single piece, not split in half and glued, simply for strength or something. Then laser cut is your way to go. You need something that's strong, so you can really abuse acrylic styrene more than you can abuse a 3D printed Keyguard, but you paid a lot more for it too. As long as you're okay with there being no raised elements and no angled cuts, maybe laser cut. Does your STEM class have a laser cutter? Well, maybe you finally give them a reason to use it. And Keyguard AT has a special offer, and it could save you a lot of money. So let me mute for a second while I cough. Come on. So let me show you that offer. And there's a link to it on this slide, but you can design your own laser cut and 3D printed Keyguard through Keyguard AT. They just ask that you come up with the design, and they even specify that you can use our designer to come up with your design. What you're going to do is you're going to send them two different kinds of output, depending on whether it's going to be laser cut or whether it's going to be 3D printed. And you're also going to send them either an SVG file or an STL file. Well, we already know the STL file works for 3D printing. It's the SVG version that you're going to send them for laser cut. You're going to just email that to them, and you're going to choose your material here. There are various kinds of material you can choose from with different price points. The one thing I'd say is, and I'll show you examples of these in a moment, I would say, where is it? not jumping out at me. Mark may have removed it. There's one type here that's just not worth any extra cost. But let's talk about what it would take to get your design in a form that someone else could laser cut it for you. Turns out it's really easy. So let me get back to our Keyguard and again, get rid of all the sundry options that were inserted in there. Let's say that we tried this and tried this and tried this and it just wasn't working out. Maybe it needed to be transparent. Maybe it wasn't strong enough for some reason. And we want to get a laser cut version of it. So let's see how difficult that is. We'll go up to type of Keyguard and we'll choose laser cut. That's our laser cut Keyguard right there. You'll note that it has another option here, use laser cutting best practices. Those laser cutting best practices came as recommendations from Keyguard AT. They will specify that certain things are more likely to result in a failed laser cutting or failed laser cut Keyguard, namely or mainly things like the widths of certain elements are too thin. So when the laser comes through the second time, it tends to melt rather than cut. Or the angles of certain openings are, they need to be rounded. So we had a rectangular Keyguard to start with. When we swapped in, we turned it into a laser cut, it made it rounded rectangles instead. So there are some, excuse me, several things like that that are the recommendations. You can turn those off and because you feel you really need to have more freedom, but I recommend you leave it on. And you may still be successful either way. You'll also note again that there's totally vertical cuts here, no matter what you specified in your original Keyguard. We can just go back there and see we haven't lost anything. But all of those things will become vertical cuts to be laser cut. And let's see what it takes to turn this into an SVG file that you can send to Keyguard AT. So what we'll do is we'll go down to the section here called Special Actions and Settings. We're going to generate, we have to slide to the very bottom. We're going to generate the first layer for an SVG or a DXF file. Put some thought in. And this is, you think of this as the first layer, but you won't really see it as something truly first layer until we render it. So design, render. And this should go very fast. This is just a two-dimensional object. And it's what they're looking for at Keyguard AT. So we'll go to File, Export as SVG. And we're in the same place we were a minute ago. We have a file, we'll call it whatever, again, your ID is for this Keyguard design, and we'll save it as an SVG file. Then you'll email that to Keyguard AT, and you'll pay the price, which is, again, really reasonable, especially if you need something laser cut and you don't have access to a laser cutter. They charge $39.95 for that. And what I found is they'll let you go pretty big on that Keyguard. And let me show you. Jumping a little bit ahead here in my presentation, but I wanted to show this to you anyway. So I designed this Keyguard for a full keyboard. And it was cut by Keyguard AT for me at that $40 price. Really, really reasonable. I used the designer to do this. I'll just point that out in a little while. I also did a two-layer version of the Keyguard and taped it together. I did it in 2 parts, taped it together, and tested the fit, because now you're sending your design off to someone else who's charging you significantly more for it. If you missed something and a button or a key doesn't line up with one of your holes, well, there's no one to blame but you. You did the design. And they actually say that on their webpage. Your STEM teacher may be a little bit more understanding, but probably not much. So they say, this doesn't mean we'll design and make a keyguard from a picture you send us. This is when you want to use software to design a keyguard and you just want us to make it from your design. They're made to order and thus are not returnable. Okay, just a heads up, you want to really test your layout then. Let me bring these in too. So here are some other examples of what they'll do at Keyguard AT for you. So this is a standard, let me get this out of the way. This is a standard acrylic styrene. It's a little milky in color. That's just what that looks like. You can get this in other colors, just a few. But they also have this offer of a polycarbonate, and this is perfectly transparent. It's significantly more expensive. It's another $50, I believe. But this is milled, so it's not cut by a laser. It's cut with a tool that goes in and actually, I don't know, like sort of like a saw, but it's not a saw. It's like a router, but not a router. Well, maybe it's more like a router. Anyway, it's milled and perfectly transparent. This is polycarbonate that's printed, and so this is very strong too. And there's an option to do this. I think there are only like 2 colors you can get polycarbonate in. This is carbon fiber PLA. It looks a lot like the polycarbonate, and I do not recommend it. Do not recommend it, only because it's no stronger than the PLA Keyguard that I created, and it doesn't have the nice finish and the nice edges that PLA does. So it's printed, and it does have, you know, the slope here and everything, but I wouldn't recommend carbon fiber PLA. Here's one more I just want to show you at this point, and that is you can print out of flexible filaments too. Now, these may have a lot of uses for you. Note that the rails also move a little bit, and the overall body can move more because it's flexible. But these may be a good choice. First of all, they're completely indestructible. There's no way you can tear this apart. Well, you can. You just take 5 horses on either end to pull it apart or break it. But there are flexible filaments you can use in creating your keyguards. All right, so there's your special offer from Keyguard AT. You do the design work, they cut or print your keyguard for roughly $40. And I recommend, again, if you can, 3D print the first couple layers as a test to make sure the fit is perfect. Demo here, I showed you my really big keyguard a minute ago. You can, any PC keyboard is going to be huge compared to any tablet. So you're not going to be able to 3D print one, but you can laser cut it. And you can use our designer to design it. It's a freeform keyguard, so you're going to be specifying every one of these openings. Kind of a pain, but once it's done, it's done. Laser cutting is the only option that makes sense for this, and we use the Keyguard.at or Keyguard AT offer. I've kind of given you that show and tell and showed you the mask already for it. The first version of our designer supported 15 iPad models, and that's all. 40 versions later, it now supports 27 different iPads and 27 non-iPads. Many of those many of those new tablets were added. Bye-bye, Christy. Yep, sorry I kept you so late. Many of those new tablets were added with the help of SLPs from across the country and around the world. It's really simple, relatively simple, I should say, to add support for a new tablet to the designer. It just requires about 12 measurements and a good screenshot. And I'm happy to work with you and to add your tablet to the designer, or you can do it yourself by following the instructions on this page. But I'd really rather you told me so I can put it in the next version of the designer. Keyguards for Chromebooks. If you follow this link, it'll take you to a different Keyguard designer, so not the one we have here or we've talked about up till now, because Chromebooks are an entirely different beast. You can't use our designer. There's a different designer for that purpose. The thing that makes the process of designing a Chromebook Keyguard reasonable at all is that Chromebooks all share a standard set of keys and a standard layout. They're thin. The keys have to sit in a small well in the face of the Keyguard, or in the face of the Chromebook, because they're so thin and because the screen needs to be able to close over the top of the keyboard. That means that we have to be very creative in how we mount the Keyguard. And the Keyguard can't be much thicker than the height of a key. This can be a big problem for laser cut Keyguards, which only come in a few thicknesses. So we'll just take a look at some examples here. We are very close to being done. Here's a Chromebook it should look really typical to everyone. And it's got all the keys in it. I'd say almost every Keyguard or Chromebook has the same layout, basically, with the same, it differs a little bit here in the arrow keys sometimes, but all these keys sit down inside a well. And you need to be able to close this top right down on top of those keys. So there's not a lot of room to work with for a Keyguard, but you can design one with that designer. You're basically specifying where all these spaces appear between the keys and where each new row of keys appears. But that's all you do. And you can produce something like this that fits right on that surface. It has tabs up on the top and on the bottom for you to put double-sided tape on. And that mounts this fairly well. It keeps it in place well. It doesn't slide around on the keys as it's doing right now. The other thing is you can close fairly thin. But that also, again, means that the edge of the Keyguard doesn't raise up much above the keys. But anyone who's using a Chromebook here probably has more control mode from a motor sense or from a motor standpoint than people who are using iPads. And it's another great place, another great opportunity to use a flexible filament to design your Keyguard. Because now definitely you don't have to worry about closing this. It's not going to crack the screen. It's just too soft and flexible for that purpose, or for that to happen. And last, I want to show you some iPad keyboards. So they vary a lot in their shape and size. And the number and layout of keys varies quite a bit, but since they have to be touch typeable, there's at least some consistency. They're all laid out in a QWERTY keyboard style, but mounting the Keyguard securely can be a challenge. And by the way, again, we have another designer for Keyguards up here, specifically for iPad keyboards. Oops, finished Keyguard. I think I showed you the finished Keyguard prior to workshop officially ending. Here's a Keyguard for a Bluetooth iPad keyboard, and it's held in place by double-sided tape. So I can pull this off, but I have to break the double-sided tape connection. But it's thick enough on the outside edge that I can put double-sided tape there in a few places and hold it down. And this can be, as thick as you need it to be, because I'm not limited by the fact that the screen has to come down. And here's a wired iPad keyboard. And here's the Keyguard design for it. It includes tabs like we've seen before, but you can print the tabs very thin out of PLA and then bend them down on the vertical faces of the keyboard and hold them in place with double-sided tape, and plus one up here held in place. There's all that flexibility to define the location of the keys and the number and thicknesses of the tabs you might need. So just want to show you that there are designers for Keyguards for things other than tablets. Finished Keyguard, we saw that come off and fit pretty well. So now I want to open up things to any remaining questions, though we're already 36 minutes over. So go ahead and put your questions in the chat. Any remaining ones, we'll unmute you for this period of time, if you wouldn't mind doing that, Matt. And if we don't see any questions fairly quickly here, I'm going to just continue on for one more slide. Also, I'll say that if you don't want to ask your question now for some reason, or should a question come up at a later time, please feel free to send me your question at the email address on this slide. So I'm not hearing anything. I'm just going to move on to our last slide. So as the slide says, if you plan on designing some Keyguards, and I assume you are, you wouldn't have signed up and sat through a 3.5-hour workshop, send me your postal address and I'll send you an easy measurement tool for free. Okay, just do that. And again, if you didn't sign up for the workshop and are listening and watching this recording, listening to and watching the recording, please consider making a donation to the conference by using the email address I included on the second slide. That's all I have. Thanks for attending, listening, and all.
Ken, thank you so much for this very comprehensive coverage of 3D printed Keyguards. I know I learned a lot today, even though it is something I've been doing regularly. It's such a deep topic that there's always something more to learn. So thank you very much.
You're welcome.
Thank you, everyone, for attending. Those of you who are still here, watch for an email from me middle of this week that will have a survey and a link for your CEUs. Thanks, everyone, for coming, and we hope to see you again soon.